Good afternoon, everyone. Let us start. Today we shall learn a new chapter, Chapter 2, Map Scale of your NCERT practical textbook. Now let me present my screen. So Chapter 2, Map Scale, and about the concept and the meaning of a scale we have learned in the previous lesson. Let us read again. So what is a scale? Do you remember? Let us read. A map scale provides the relationship between the map and the whole or a part of the earth surface shown on it. So it means that a map scale shows the relationship between the map and the earth surface. Okay, so as we learned earlier, so here we have a map here, and we have two features, x, y. Okay, and here on the surface also there may be corresponding points, okay, on the surface. For example, this is x, and here we have y. So the relationship between, okay, these features on the map then on the ground is known as the this map scale. Okay, so we can also express this relationship as a ratio of distances between 2 points on the map and corresponding distance between the same 2 points on the ground. So as indicated here, so we have 2 points here, x and y, okay, and the map is the ratio, the mathematical relationship between these 2 points on the map and the corresponding 2 points on the ground. Okay, so the ratio between the distances here on the map and the distances on the ground is known as map scale. Okay, and there are at least three ways in which this relationship can be expressed. So map scale can be expressed uh, in three ways, and these are: number one, statement of scale; number two, representative fraction, that is RF; and the third one, graphical scale. Okay, so these are the three ways to express the map scale. I think you may be clear about the meaning of the scale. So scale, this is the uh, relationship between the distances on the map and their corresponding distances on the ground. Okay, that means every point, okay, depicted on the map, okay, has a corresponding relationship, say in terms of area or distance on the ground. Okay, and next we have these methods of scale. So before we continue, are you clear about the meaning of the scale? Any question regarding the scale, about the meaning of the scale? Okay, if you don't have questions, then let us continue. Let us proceed. So methods of scale. We have three methods of representing this scale as read earlier. So the first one is the statement of scale. Okay, so this is the first type of scale. Let us read. The scale of a map may be indicated in the form of a written statement. Scale of a map can be indicated uh, in the form of a written statement. For example, if on a map a written statement appears stating 1 centimeter represents 10 kilometer, or 1 centimeter to 10 kilometer, say somewhere in the corner of a map. For example, this is a map, and somewhere in the corner you may find it, okay, say writing 1 centimeter represents 10 kilometer, or 1 centimeter to 10 kilometer, or 2 inches to the mile, like this. Okay, you may be seeing such type of this written statement in a corner of map, and this is what we call statement of scale. So it means that this statement scale means that map distance, okay, a map distance of 1 centimeter is representing 10 kilometer of corresponding ground distance. So 1 centimeter to 10 kilometer means that, okay, a distance of 1 centimeter here, a distance of 1 centimeter on the map represents, okay, a distance of 10 kilometer here on the ground, a distance of 10 kilometer. Okay, in this case, 1 centimeter, a distance of 1 centimeter on the map represents a distance of 10 kilometer on the ground. So this is the meaning of this statement scale. Okay, so it may also be expressed in any other form of measurement. Not only in terms of centimeter, it also can be expressed in terms of inches. That is, 1 inch represents 10 miles. Here in this case also, it means that a distance of 1 inch, okay, a distance of 1 inch on the map represents a distance of 10 miles, okay, a distance of 10 miles on the ground. And you must know that one limitation of this method, that is one demerit, okay, the drawback of this method is that if the map is reduced or enlarged, the scale will become redundant, means it will become useless, and a new scale is to be worked out. Okay, see, sometimes you want to enlarge the map. For example, this is a small map and you want to make it bigger. Okay, you want to make it bigger. That is called enlargement of map. And when your map is enlarged, okay, such type of statement scale become useless, meaningless, invalid. And that is why we need to calculate a new scale for the new map. So this is the disadvantage of statement of scale. Okay, similarly, when a big map is reduced, okay, when a big map is reduced to a small one, then in this case also the scale becomes invalid and we need to calculate a new scale. So this is the disadvantage of statement of scale. Okay, are you clear? Any question? Next we have the second one, okay, the second method of representing scale, that is a graphical or bar scale. So the second type of scale shows map distances and corresponding ground distances using a line bar with primary and a secondary divisions marked on it. And this is referred to as the graphical scale or bar scale as given here. Okay, so this is an example of graphical scale. It is also known as bar scale or linear scale. Okay, so here in this type of scale you will find two divisions, and see here this side, okay, this side is known as primary division. Okay, this side is known as primary division, and this side is known as secondary. Okay, secondary division. And here in this case, see this distance, this much distance represents 1 kilometer on the ground. Okay, here from here, this one also, this much distance on the map represents this 1 kilometer on the ground. And here on the secondary section also, you'll find subdivisions of the kilometers. Here it is representing in terms of meter. Okay, here up to here is half kilometer, that is 500 a meter, and this is a 1 kilometer. That means 1000 meter is equal to 1 kilometer, and these are the fractions. Okay, see here 0, 1, 2, 3, 4, 5. That means each division represents 100 meter. Okay, here 100 meter, 200 meter, then 300 meter, 400 meter, and 500 meter, so on, up to 1000. So this is another method of this representing scale. Okay, map scale. And unlike the statement of scale discussed earlier, okay, the graphical scale stands valid even when the map is reduced or enlarged. So in this case, when the map is enlarged, okay, or reduced, the scale becomes still becomes valid. Okay, still stands valid. It doesn't affect the enlargement or reduction of the map. Okay, when the paper is reduced, okay, when the map is reduced using a Xerox machine, this scale also will be shortened, so it becomes a valid one even if it is reduced or enlarged. Okay, so this is an important advantage of graphical scale. Remember, graphical scale stands valid even when the map is reduced or enlarged. And next, we have the third method of representing map scale, or the third type of map scale, that is representative fraction, RF. So it shows, this RF shows the relationship between the map distance and the corresponding ground distance in unit of length. Here RF shows the relationship between the map distance and the corresponding ground distance in unit of length. And RF is generally shown in fraction because it shows that how much the real wall is reduced to fit on the map. For example, a fraction of 1 is to 24,000 shows that 1 unit of length on the map represents 24,000 of the same unit on the ground. Or say 1 millimeter or 1 centimeter or 1 inch on the map represents 24,000 millimeters or 24,000 centimeters or 24,000 inches respectively on the ground. Okay, and this quality of expressing scale in units of area makes it universally acceptable and a usable method. So this one is universally usable one. Okay, universally acceptable and usable method because it does not give any unit of this distance or measurement. It gives simply a ratio as given here. See, 1 is to 25,000. So it means that, okay, so here we have a map and we have corresponding ground. Okay, so what does it mean? It means that a unit of distance, okay, a unit of distance on the map represents 25,000 unit of distance on the ground. Okay, and you can replace this by any unit. For example, if you have replaced this one as centimeter, that means a distance of 1 centimeter on the map represents a distance of 25,000 centimeters on the ground. Or if you replace it by this millimeter, it means that a distance of 1 millimeter on the map represents a distance of this a corresponding distance of 25,000 millimeters on the ground. And likewise, say for example, if you are using this inches as a unit of measurement, It means that 1 inch on the map, okay, 1 inch on the map, a distance of 1 inch on the map represents a distance of 25,000 inches on the ground. In other words, RF shows that, okay, a unit of distance of 25,000 has been reduced to 1 on the map. That means a distance of 25,000 centimeter on the ground has been reduced to 1 centimeter on the map. Okay, as given here, see. It shows how much the real world is reduced to fit on the map. How much the real world is reduced to fit on the map. So in this case, okay, 24,000 centimeters at distance of 24,000 centimeters on the ground is reduced to 1 centimeter on the ground. So we have to read like this. And in this case, a distance of 25,000 centimeters on the ground has been reduced to a distance of 1 centimeter on the map. So this is the way of reading representative fraction. Okay. So are you clear? Any question? Okay, if you are clear, then we shall conduct some activities on conversion of scale. Okay, the first activity is about statement of scale to RF. Okay, we have to convert the statement scale into RF. So activity 1, convert the given statement of scale 1 inch represent 2 miles into RF, into representative fraction. So we need to convert this statement scale into RF. Okay, so here we have the solution. So as given in the question, okay, 1 inch represent 2 miles, means 1 inch is equal to 2 miles, or 1 inch is equal to, okay, 2 into 63,360, because 1 mile is equal to 63,360. Okay, that means as given here, 2 miles into 63360, because 1 mile is equal to 63360. That means 1 inch is equal to, okay, 1,26,720 inches. So this is the RF of the given statement. Okay, so it means that that 1 inch is equal to 2 mile, okay, is, okay, this one is equal to 1 inch represent 2 miles is equal to 1 is to 1,26,720. So this is the RF. Okay, then we have this another activity. Okay, activity 2. Find the RF when the scale is 2 inches to the mile. So this is the case of large scale. The first one is the case of small scale, and this is the case of large scale. Here 2 inches is equal to 1 mile. That means 2 inches is equal to 1 mile. Okay, it implies that 2 inches is equal to 63360, because 1 mile is equal to 63360. Now RF is always expressed in terms of a fraction in which the numerator is 1. So we have 2 is equal to 2 inches is equal to 63360, or 1 inch is equal to, you have to divide this value by 2. Okay, and we have got this, and so this is the RF. So RF is equal to 1 is to 31680. So this is the RF. Okay, remember in this case we have to divide it, because here the numerator is 2. it is like this. Here it is like this. It 263,360. So we need to convert these two to 1, and that is why we are dividing this value by these two. Okay, so in this way it means what? 1 by 31,680, or 1 is equal to 31,680. So this is the RF. Okay, and next we have this another activity, that is in this case from representative fraction to statement of scale. So here we have to convert the RF into statement of scale in metric system in the first case, activity 3. Okay, so we have the question: convert RF 1 is to 250,000 into statement of scale in metric system. So here the RF is 1 is to 250,000. Okay, so 1 is to 250,000 means that a unit on the map represents 250,000 units on the ground, just as we learned earlier. Okay, here this is the map, and so here it means that a unit of distance on the map. Okay, here this is a unit. A unit of distance on the map represents, okay, 250,000 units of distance on the ground. Okay, so if you give centimeter, then it will become centimeter. That means 1 centimeter on the map represents 250,000 centimeters on the ground. Okay, here it is given here. 1 centimeter represents 250,000 centimeters on the ground, and it is to be divided by 1 lakh because we need to give in terms of kilometer. So we are dividing this value. We are dividing these 250,000, okay, by 1 lakh because 1 kilometer is equal to 1 centimeter, 1 lakh centimeter. So after dividing these 250,000 by 1 lakh, so we have got 2.5, okay, kilometers here, as you find here. And again, we have the last activity here. Okay, activity 4. The RF of a map is 1 is to 250,000, and what is the scale in terms of miles to the east, to the inch? Okay, British system. Okay, English system. The first one is about metric system, and here we have got the same RF, but we have to express in a British system. Okay, what is the scale in terms of miles to the inch? So we have the solution. Okay, so it means that 1 is to 250,000 means that a unit, 1 unit, okay, 1 unit on the map represent 250,000 units of the ground, or 1 inch on the map represents 250,000 inches on the ground. Okay, just it is the same as indicated earlier. Here it means that 1 inch on the map is equal to 250,000 inches on the ground. Okay, so this is the ground. Or 1 inch represent 250,000 divided by this 63360, because we need to express in miles as we learned earlier. Okay, 1 mile is equal to 63360 inch, and that is why we are dividing 250,000 by 63360 just to convert it in terms of miles. Okay, so after dividing 2,50,000 by 63360, so we have got 3.94 miles, and hence the statement scale of the given RF is 3.94 miles to the inch. Okay, 3 point, yeah, 3.94 miles, okay, is equal to 1 inch. So this is the answer. Okay, are you clear? Any question? Okay, if you don't have questions, let us stop here for today. Thank you very much for joining my class.